Hello students, hope you are doing well. So this course is soft computing and my name is Dr. Ankur Bist and I will teach you basics of soft computing. Okay. So during this course, what is the first point is what is the objective of this course? So the objective of this course is to make you aware about few techniques that can be applied when we don't have direct solutions in the subjects like data structure, design and analysis of algorithms, computer network, Python. You have seen wide range of programs. If you design the program, there is certain input and you get output, fixed output, okay? But what happens if the problem is too complex or the problem belongs to the real world? Then sometimes we don't have the direct solution or program to generate the end outcome. So in that case, we need something that can bridge the gap between question and answer or problem and solution. So this subject is something is this subject will tell you about that dimension of programming. Okay, so nowadays I think all of you are aware about AI. So yeah, so it soft computing tends to AI, it tends to fuzzy logic and genetic algorithms and other related things. Okay, so let's come to the point. The second slide is the definition of soft computing. So as I told earlier, there are two things: hard computing and soft computing. So let's take example of linear search. So there, what happens in linear search? What is the input? There is n elements, okay, and if you want to search a element x, then you write the program, okay, and then the index, then in different index you match the element, and finally when you find, compare the value and you find the result and return the value, okay. Okay, whether that element is present or not, or at what position it's present. But now change the problem instance in the problem scenario. Suppose I told you to design a program that can detect what will be the temperature, what will be the weather condition tomorrow. So suppose if you want to write the program, so there are not fixed values available like linear search, because this is real time scenario and depends on an n number of variables. So how will you solve this problem? You cannot solve it directly using conventional programming. You have to design some different kind of logic, because what happens what happens if I talk about normal programming, we have fixed parameter, fixed set of conditions, but in scenario like weather prediction or stock market prediction or some these kind of scenarios, the variables are very different. There are large number of variables, and some variables are unknown variables. So the question arises: if variables are unknown, then how are we predicting the solution? So we collect variables, we collect data, and we select some important variables and then perform tasks. So the second line of the slide is saying it uses imprecision, uncertainty, partial truth, approximation as input. Yeah. So that's the point. So all these things are taken as input, because if we know everything, then it can be solved with the hard computing, okay. So we don't know something, there is some gap, there is something that is yet to be known. That's why we are moving towards soft computing. I think that these many examples are sufficient to make you aware about the definition of soft computing. And the second, another important point that you must know, that industry is basically moving towards these techniques. Of 10 years back, all these things are just were just in theory, but now with the advancement of hardware, with the advancement of algorithms, with the advancement of cloud-based resources, now it's easy to implement all these things. Okay, so in coming lectures we will discuss in detail. So now next slide is what I have explained already. It's written in terms of few bullet points. If we talk about hard computing, then there will be precise values, fixed output, accurate output, okay, used in critical systems, because we cannot approximate when the situation is very, very critical, okay. But in soft computing is used generally in decision making tasks, okay, and there are certain assumptions, hypo assumptions, and we play over data and assumptions, okay, and we try to reduce error and maximize the accuracy of our prediction. Now, what are the techniques used in soft computing? So there are various techniques, okay. If so one semester is not sufficient to cover everything, but yeah, after at the end of this course you will be aware about few basic techniques, okay. On the top of that, there is whole ocean of knowledge, but these are the basic things from where the journey begins, and if you have good knowledge of basic things, then yeah, you can extend it, okay. So the topics are fuzzy systems, neural network, evolutionary computing, machine learning, and probabilistic reasoning. So these terms may be new for you, or maybe in some online courses. Okay, you may have heard about these terms, so we will take in detail. I think neural networks are very common nowadays, and because AI is buzzword in the market, so this term is common, but machine learning and neural network, but evolutionary computing, fuzzy systems, and probabilistic reasoning is not that much common, but this is the base, okay. So we will understand, we will take these terms in detail, okay. So the first is neural network. So this is introductory lecture, so I will just a brief of these things. So what is neural network basically? So our brain is composed of neurons, and it generates intelligence. What is intelligence? Another big topic of discussion. How we define intelligence? Okay, it's a very, very big question, and different companies, majorly just like Google, Microsoft, Amazon, are doing research in the domain of AI, in the domain of artificial neural network, and all these things they are doing. But one company, I think all of you must know about it, that is AlphaGo, okay. uh, I'm sorry, DeepMind that created the AlphaGo, okay. AlphaGo, so AlphaGo, uh, it's acquired by DeepMind, was acquired by Google. So they defined, they defined intelligence for their systems, okay. They are, because they are creating some intelligent boards or intelligent programs who can play with the professional players of different games, and their algorithms are performing well, and they published their first work in Nature, that is very well known journal, okay. So it's a very big thing, it's a very broad area, but uh, at the introductory lecture I will not go in deep. I just will say that neural network is a kind of program that takes input certain variables or features and predicts output accordingly, okay. It was founded by in 1940, okay. Warren S. Moloch, okay. He's the inventor of some very basic, very fundamental thing in this area. So it's inspired from our brain, as in our brain various neurons are there, and those neurons take input from eye, ear, and from skin. We touch the things, so there are different sensory organs. Input goes to brain processes the input and then responds. Okay, similarly a computer program is made and all to perform various kind of activities, okay, to predict something or to take certain kind of decisions. Okay, so the end goal of artificial intelligence is to make a system that can take decision by its own. Okay, so it's a very big vision. Okay, things start with a big vision. If we don't have the broad vision, we cannot attain great things in life. And science, objective science is always great and big. Another big thing is fuzzy logic. So Lotfi Jade, okay, so there is a very great researcher. He invented the fuzzy logic. Okay, so fuzzy logic, actually, you in digital logic, I think in third year or second year, you have read computer science works in 0 or 1, either it's truth or false. But he designed something new. Fuzzy means the logic, the value may vary between 0 and 1. Okay, uh, both are inclusive. Okay, both are with inclusion. So what does it mean? That this concept brought fuzziness in the system. Okay, what is the advantage of this fuzziness? So when we combine the systems like neural networks and with the fuzzy logic, then we may get something like neuro fuzzy kind of systems, where overall functionality with this combo pack performs various tasks of optimization plus decision making. So we will go in detail how fuzzy logic based systems help us to determine activities of different scale. Okay, so as written in the slide, also the most applications in control systems and decision theory. So now the next is the machine learning. So these are the concepts: neural network, fuzzy logic, and machine learning is somehow the superset of of neural network. Actually, neural network and all these things comes under machine learning, deep learning kind of terminology. So machine learning, what is machine learning? It's again written supervised, unsupervised. Machine learning means again uh, to to design a program where it learns, we provide some data, it learns from the data, it predicts. Supervised means there is one instructor. One instructor means suppose a child, wow, when first time sees the apple, so does not recognize what it is, but the parents tell you this kind of structure and color and shape, this is apple. So he or she recognizes with the time, and when again the same kind of object comes, he or she says, yes, it's apple. So how does it happening? It's kind of learning of child with the help of parents as instructor. So it is a supervised learning. And second, in unsupervised, when there is no one, no teacher, no instructor, and learns by its own. Okay, learns by its own. The system learns by its own. So that's just like we can take the example of uh, yeah, in network, for example, uh, data packets are coming in the network. Okay, so there are some good packets, some bad packets. Means some packets are benign, some packets are malicious. So suppose I put one seed packet that is malicious, and I calculated the similarity index in the space. So there will be two clusters. Okay, so it's just a kind of unsupervised learning. Okay, I'm not labeling, but based on some properties, clustering or some classes are being developed. Okay, next We will take these topics also in detail. Okay, for the first simple understanding, you can understand. If someone, their instructor is there, then it's supervised. Without instructor, it's unsupervised. Advantage, what are the advantages? Because if we don't have anything, and for getting a solution, and someone says that use this, it may give 90% result, then it's better to substitute. Instead of nothing, you have something. But when something, intelligence acquires intelligence, or something grows with time or becomes accurate, then it becomes useful and real time end-to-end systems. So what does it mean? What does it mean to say? I mean to say that it makes system intelligent. First thing, it provides the capability of taking decisions. Sometimes it makes system fast and easy to integrate. Okay, applications, the n number of applications. If it's a space to, I talk about self-driving cars, self-driving, uh, sometime bicycles, or something, some robots, or I can take example of yeah, home appliances, and I take example of gaming. I take example of simulation generation. Take example of yeah, you have seen in COVID, mask detection and all these things, facial detection, all these things. There are endless applications. Okay, so it's very interesting. We will cover. Okay, and during this course, these are different interesting diagrams showing application. Just the very rough diagrams, very basic things. Okay, robotics, and some arm is there that is putting something into some box. So yeah, I think in LinkedIn or in some social media, you have seen this kind of hand. Okay, it's developed by not this, something like that is developed by OpenAI company. They developed something with the help of reinforcement learning. We will take all these things. Okay, in first lecture, I don't want to make it complex. I hope that, thank you. Okay, I hope that during this basic introductory lecture, you got some basic idea. I welcome your queries and questions. We will discuss and explore the things. Okay, so being the final year student, I am hoping that you are mature enough, and I will provide some assignments and all this, some basic things, some basic problems, and you will answer them well. uh, okay, thanks for listening me and watching this slide. Thank you.